Hello and welcome to another Mr. Betabyte video, and this one's a little bit different insofar as we're looking at a PCM 701 ES from Sony, and it's a PCM encoder decoder, digital audio processor, and I have looked at one of these before, and I am still working on the PCM F1 as well. All these are from the same person, so hi Eric, hope all's well with you. And this one, as you can see, or you might be able to see, is for parts only. It came to me sort of taped together and basically with no display. Now the other one that I had, basically the playback muting switch was bad. And what that turned out to be, if you haven't seen that video, was the lug had broken off on the back of the switch assembly, the plastic assembly, and somebody very kindly glued it in with super glue, and well and truly did a good job. And I have started trying to sort of hack this out, but it's not going terribly well. But I will need to sort that if this indeed will work. So this one obviously has been, well, I would say has come from a broadcasting environment. The main reason I say that is it's actually got quite an interesting addition on the back of it. So I actually know nothing about this add-on. I'm guessing it must have been it was a third-party add-on for these units to use in a professional environment. And this is audio plus design on there, and it's got the digital interface and remote, which would make me think that this would have interfaced up with maybe Umatic machines, maybe early Betacam for control. And yeah, it's quite a beefy addition to the unit. So I just think with that in mind, it's worth trying to save if we can. But this unit is high hours. Yeah, just looking at the general condition of it, it's been well used and well loved. So yeah, let's crack on. Overall impressions of this, just initially looking at it visually, like I say, it's high hours. You can see down here where the board has been burnt somewhat from heat, and down here as well. It's although there is sort of glue there, you can see it's got a bit hot, and I would firmly believe that probably these relays are going to be a bit noisy as well if we do get it going. But yeah, the fuses look good, which is always a good start, and I assume they will be good. I'm guessing the rest of the unit may well work. We have got this DC-DC converter here, similar to the PCM F1. It's much smaller than the PCM F1, and indeed the reason I'm looking at this is because the PCM F1, I'm waiting for parts. It has been a nightmare doing that unit, just the amount that was wrong with it, but it's all down to the DC-DC units providing too much voltage. Basically the regulation was really poor, but that'll be in another video which has taken a long time to put together. So yeah, I suppose the next thing we need to do is find a cold kettle lead, IEC lead, and power it up. So I've found a mains lead and put that on, and I thought, well, I'll just put the meter across the fuses just to double check there was no stress breaks, which can happen with old fuses. And I thought, oh, I'll just put the switch on ready. And I thought, well, it's easy enough to check. I'll just put the meter across the main switch contacts, and Let's move you back a bit. So, on. Oh, and it's now working. I love it when stuff proves you wrong. Super. So that is working. It wasn't. I was basically working this, and yeah, it wasn't working. Super. So that is now working. So let's give it a try. So here goes. I'm going to wind this up. I don't know. If there's no display, I don't know what else we're going to see, to be honest. I can't remember what these are like when you wind them up. Yeah, so we've got nothing. So I suppose we ought to see if there's anything going on. Minus 35 volts, minus 5, and so negative voltages this side, positive voltages this side, I think. Maybe? No. Minus 5, minus 5. So that's all. Ah, right, okay, so that's just fusing. Fusing control. Okay, so I think the next thing I'm going to do is actually check if I've got any continuity actually on the mains. Let's check that's okay. Because to me it's dead. Neutral. Live, good. Good, so I've got continuity right the way through past the switch. So where does that go? That goes to this board. Yeah, it just literally goes straight into that DC-DC converter. So let's get this out. I'm sure that'll be really easy. That's interesting. It uses C6 style screws. So I like C6 screws, but with a washer on as well. So yeah, that's interesting. Oh, not easy to remove. Very heavy. It's amazing how solid this is. It's just a brick. And as you can see, it's not overly serviceable in some ways because in the interests of keeping these things reliable, everything is wire wrapped for the interconnects, so there's no plugs, sockets. If nothing else, I mean, I don't know how much Eric wants to spend on this, especially as it is pretty high mileage. and he has got other units. Might end up being better as a spares unit, but now, is there anything else I need to remove? Because I did spots. There we go. It's just a big transformer. So it's not a DC-DC converter at all. So it's actually worth knowing, hence the weights. It's a massive transformer. I mean, it's beautifully potted and excellent build quality. So I suppose the next thing is to that actually makes a lot of sense, because I noticed when I was taking it apart there's actually rubber dampers. So did you actually see in there? Yeah, you did. So let's get this back together. Okay, well, it looks like I've been caught out by a dodgy connector on my variable AC power supply again. Because if I power it on, green LED, and the relays activate. So, oh, and we have a display. Oh, that's fun. Only the left is showing. That just briefly went off. It's just a matter of bad joints. Or bad joints. Yeah, it's not as simple as that, because if I activate sort of playback mute, although of course I've got no input outputs, so it will do that. We might be okay. We might just need a bit of a resolder. So let's crack on and do that. Wow. So I don't know how well any of this is going to come out, but it's actually a bit involved getting the metal shield off. The actual unit itself is easy to get out. It's just two screws here and here. But there is glue and some description. And it looks like there's a couple of like pressed-in clips as well. By pressed-in clips, I mean clips that are pressed into the shield that sort of lock it in. So I'm just using a plectrum. I have been known to repair iPads, so I have a lot of plectrums. I don't play the guitar. Which I did, because it'd be a very relaxing thing to do after some of these jobs. There we go. So covers off. Well, there's actually no solder on that at all. It's just literally just floating about. And the rest look okay, but I'm sure there's probably bad joints I just can't see in this light. Let's see if we can actually get that round. Power it up. again. Oh yeah, it's completely broken now. I've just moved that end one and it's completely broken. It is trying to. Obviously fairly high voltages across this, but won't do me any real harm, I don't suppose. Yeah, so it might not be quite there, might not be as simple as just dry joints. But I think what I'm going to do is I'm going to resolder all of these top joints anyway to start off with. I seem to remember pulling this up a little bit. Maybe? No. We've actually got anything at all there. Yeah, so green LED's on. Let's see that in the camera. Yeah, well, I think I'll just go through it. I know this heater connection is bad, if nothing else. Yeah, it's still trying to, isn't it? Okay, well, I'll go through it, get the magnifying glass out as well, and have a look, and we'll take it from there. So, the VU meters are now working, or the display is, in its entirety, and what it turned out to be was all of the pins at the bottom of the microcontroller chip here were bad. The joints were bad. So I've resoldered them. It was quite messy before, so that's not me. I will clean this up a bit though, but you can see where there's quite a lot of flux, to be honest, all over the board, and you need to see where the flux burnt a little bit there. But yeah, I've reflowed it and used this solder, which is very, very fine, and just normal iron. I was contemplating possibly using hot air, but I just thought, well, this sort of age of surface mount, probably if I can get away with normal solder and a soldering iron, then all good. So that is working. Let's give it a tap. So it's all good. Now, I think what caused this, and this is something worth noting, is the screw that was through the bottom of the chassis here was actually the wrong length. It was too long, and basically it was pressing on this board and sort of pushing it out of the way slightly, sort of bending it, flexing it. And I think it's just literally just taken the joints over time with movement. The joints have all just become bad. Now I have resoldered the back of this, and I'll show you a before and after of the soldering there, because there were quite a few suspect joints there, to be fair, as well. So worth doing. And but yeah, really pleased with that. That's working. So the next thing I'm going to do is I probably will just pop the tops off these relays, because these do have a habit of getting noisy with age, and this is a high mileage unit, so it's worth doing. And then we'll give it a test, which would be great. Looking forward to that. So, bodge of the century. I'm getting quite good at these, aren't I? Yeah, it should work. It's just really to keep the button in, so it doesn't fall out. Just glued a tiny bit of, it's actually a bit of plectrum, just to stop the button from falling out again. And hopefully that'll be enough. It feels horrible, but at least it works. You know, that's the thing, I've got it going. It's just not a very elegant way of doing it, and why anybody would just super glue the button back in, you know, stick a bit of tape over it or something maybe, I don't know, but gluing it in so it would never work again without a good hack with a knife or something is a bit crazy. But anyway, it does work, so I'm pleased with that. But I just thought, while the bottom cover's off, we'll just have a look at the absolutely brilliant build quality of this. I mean, all the copper, even the black top and bottom covers are copper. And it's interesting, there's this additional relay here, and I think this is probably something to do with the back here, but maybe somebody could let me know in the comments what that might actually be for. It's a bit interesting how it's all wired in, to be fair. If it was a Sony edition, then it's certainly an afterthought, but looking at all of this, it does all look like signal, and yeah, it actually goes up, all of this goes up to the record switch, the record level. So I don't know, it's an interesting one, that's quite what's going on there, but yeah. So there we go, it's working. It's actually working really well. A little bit of playing about with the switches on the back. I've realised what that one relay is for. Well, I say I realise what it's for. I can hear it being activated when I flick the switches on the back. Just have to work out which switch actually activates that relay, I suppose. But yeah, please do let me know. And yeah, it's really good. Turn it up, got it through headphones. Hopefully you'll hear that. And yeah, really good. The only problem I've really found with this is at the lowest volume level for the headphones, only one channel is working, so that's not ideal, but otherwise it's fine. And outputs seem fine as well, which is great. So yeah, it's actually really good, and the playback muting switch works. Record mute. The buttons have been removed for the 14 and 16-bit switches for the recording resolution. It's stuck on 16-bit, which is fine. You can stick a screwdriver in there if you wanted to change this. Don't know why you'd want to. And yeah, so there we go. I'm playing back on the Toshiba V9600, which does a really good job actually with PCM recordings. So with that, thank you very much for watching. Hope you enjoyed this one. Something a bit different, definitely. And see you in another video. Bye for now.